This is our 9th Graph Guru webinar. We're super excited that you're here with us and learning about the most recent graph solutions with TigerGraph. Today's presentation is how Visa optimizes network and IT resources with a native parallel graph database. My name is Emma Liu. I'm helping to moderate the webinar today. A couple of housekeeping items before we get started. You're muted by default, but you can talk to us via chat in Zoom. If you have questions, you can submit through the Q&A box, and we will address them at the end of the webinar. And the session is being recorded, and after the webinar, we will provide the link to the recorded presentation. Please note, you should update to the latest version of Zoom to avoid bugs. Some of the previous attendees had issues keeping the connection with their older version of Zoom. I want to mention that with our most recent TigerGraph 2.2 release, we have a new Docker download and a VirtualBox version for our Developer Edition so that you can install TigerGraph and learn about TigerGraph on your laptop. This is a beta release for the Docker and VirtualBox versions, and we welcome your feedback. Let me introduce myself. My name is Emma Liu. I'm a product manager at TigerGraph. I've worked previously at Oracle as a software engineer and at MarkLogic as a product manager. My focus here at TigerGraph is on cloud, containers, enterprise infrastructure, monitoring, management, as well as connector ecosystem. Joining me today is Xingyu Chang. Xingyu is our solution team lead, and he has been with TigerGraph for 4 years. He is co-author of our proprietary graph query language, GSQL. Xingyu has been leading our solution engineering teams and created many solutions and demos for most of our major customers. He is our expert on graph solutions and algorithm with TigerGraph. Today, Xingyu will tell us how he approached the network and impact analysis for the Visa use case. This is a generalized use case where Visa adapted to our recommendations. Let's look at a few staggering numbers. $15 billion. This is the yearly loss due to the mobile network outage for the mobile operators per year. $5,600. According to Gartner, this is the money wasted because of IT downtime per minute for one organization. 84%. This is the over-provisioned computing or memory in cloud platform. Yes, cloud computing is convenient for organizations, but it also introduces lots of wasteful consumption if you don't manage it well. With TigerGraph platform, our foremost design philosophy is to solve our customers' pain points and help drive better business outcomes. Do you want to increase your top line and bottom line? Have you thought about how to reduce costs and manage risks in your business operation and improve operational efficiency? Many Fortune 500 companies have achieved dramatic business outcome from the real deep link analytics from TigerGraph. The ROI, return on investment for these companies using TigerGraph, has been tremendous. And today, we're going to talk about a solution case which Visa has chosen to adapt to their internal IT organizations to optimize infrastructure, minimize outages for critical workloads. How can TigerGraph help you? A good news for everyone in the audience, we have created 14 new use case solutions for our customers. These solution sheets will help you understand how TigerGraph can help and facilitate your digital transformation. There are 3 main categories that TigerGraph is positioned to help you to analyze all the interactions in real time to sell more, reduce costs and monitor your risks effectively, as well as manage resources for the maximum output. In addition, we have 3 foundational use cases around geospatial, time series, AI, and machine learning. Our webinar today is related to the network, IT, and cloud resource optimization. We will have more guru webinars around these solution sheets. Here is the URL links. We will have more links at the end of the presentation. Let me go back to the main agenda today. We're going to explore the network and IT resource optimization with Graph database and why TigerGraph is fitted for the network and IT resource optimization. And Xingyu is going to walk us through the use case in depth and follow with a demo. I want to start with the generalized use cases implemented at the major credit card company. This project aims to provide a complete view consisting of business groups, business services, applications, servers, and disk storage. Based on this complete view, we can answer many types of questions to understand the impact of the business. If any of these application goes down, and we can take actions proactively to reduce the service downtime and also reduce the disk storage cost. Whenever an alert happens to one of the components in the organization and enterprises, we can understand its impact downstream. And the challenge in this case is the IT infrastructure is very complex and they are very interconnected. We need to find out the component outage or capacity overflow. With TigerGraph, we provide the following solutions. We can maintain the real-time operational map of the interconnected resources. And we process the IoT sensor signals from the physical storage, server, and network equipment to identify the at-risk components in real time. And we can identify the network elements which are likely to max out based on the physical and promised capacity and traffic. And we can take proactive remediation, proactive actions and measures to help you avoid problems in your organizations. Cutting cloud spanning is a big topic as well. We will cover it in a future webinar on this topic. To improve the operational efficiency, the modern enterprise data really requires a modern technology enabler. And as we're looking at the problem space from the enterprise IT operational map to the cloud resource cost reduction, as well as getting the graph insights from Internet of Things network. This is increase in complexity and data size requires a modern graph platform to give timely insights. And with traditional relational databases, investigating and finding the peak workloads by different business units, it will take a long time to finish computation with multiple database joins. This will cause delayed business insights. Some of the common network and IT resource optimization questions people are asking. For example, which teams' production servers are over-provisioned and how big is the impact? And some organizations are asking, what's the peak workload in application A? And where is the bottleneck? And what's the recommended actions from the server status by different teams? With relational data DBMS, it is not really designed for this type of complex link analysis. in real time. And there's no easy SQL for answering these questions. For TigerGraph, cloud computing and IoT devices are already on a graph. So it's naturally modeled in a graph database. And TigerGraph is designed for these type of discovery types of analytics. And the proprietary query language, GSQL, it's very expressive, and we can efficiently solve these type of complex query. So why TigerGraph for operational network and IT resource optimization? So that you can have an efficient operational IT stack. There are a few benefits. Some unique TigerGraph features that will help you to achieve this. First, it is fitted for real-time operational map for large amount of data. And TigerGraph handles continuous data streaming, and it's both transactional and can visualize the operational map of these devices. You can imagine that you're collecting a lot of data continuously in these IT infrastructure, and it is a lot of data. And the depth of the traversal for the entity relationship is enabled by TigerGraph's architecture, MPP architecture, and TigerGraph is a native parallel graph database. We can, with TigerGraph, you can also add the geo and time series data, and it will enrich your graph applications. Thirdly, but not the least, TigerGraph has the industry-only multi-graph access control, which allows you to separate your graph into multiple business units and allow separation of control on expenses and usage. In many industries, we can use TigerGraph to analyze the network impact and IT infrastructure. With that, I'm going to hand it over to Xinyu, and he's going to walk us through the use case in depth.
Hi, everyone. This is Xinyu from TigerGraph. I will show you the very classic 3 steps on how to create a TigerGraph solution to solve this IT network and the infrastructure management problem. Okay, so in the beginning, I will show you that this project has been done by integrating many data sources. We have the storage data, servers info, where the servers are deployed, what part of the storage has been assigned to each server, and also application data, that is like on which server the applications are deployed, and and there's also service data for each service. It had it include what application, and also the event data. Event can be like alert, warning, error, or any event that happened to this infrastructure, and also the owners of this of each services. It's like if something goes wrong, who should be the guy that we contact? Yeah. So before they made all the data may be stored in different tables, or even they were isolated before, but now they are in the one graph altogether. Okay. So this is the how I created the graph schema and the data loading. On the left-hand side, you can see that the graph schema I created for this solution. This is a multi-layer schema. On the bottom, you can see we have storage array, and one storage array may have multiple pools as its logical structure, and each pool may have multiple lungs, right? That is a unit of storage, and this is also a logical structure. And lungs can be assigned to host the server, because when you start a server, you need some disks, right? And that is actually from the storage system. And on each server, applications were deployed, okay? And you can see also there is a nudge between the applications. That means applications are sending calls to each other, right? So that they also are like depending on each other, or they need to send a message to one another. Okay, so and for one service, it may need the support of many applications, and for each service, we have a manager. Okay, so after outside this multi-layer architecture, we have warnings, right? Warnings are attached to the application, and for each warning, it belongs to a certain warning type. And between the storage array and host server, there is a physical connection that is through switch, right? So actually, the host servers are physically connected to storage array over these switches. That is a physical connection. And this storage array pool long relationship are logical relationship. Okay, this is the graph schema. And for the data loading, you can see that I loaded seven input files to construct the graph, and I utilized the GraphStudio to do the mapping in order to create those vertex and edges. Okay, so based on this graph schema, I have created three different use cases. Okay, so let me show you from GraphStudio. Okay, so the first use case is called app impact, because we know that from the graph schema that we have one application may call another, right? So the question we want to ask here, if one application goes wrong, what would be the impact to the entire application network? Okay, so this query takes three parameters. The first one is application ID. That's the application goes wrong. And the other one is a decay number. That is, the further away an application is from the problematic application, the lower score it will get. And then K, I want to see the top K applications in the result. That is a top K impacted application. Okay, and I run get the result. Okay, so this is the subgraph I traversed. Then I can do some trick to highlight those applications that has higher score. Then here I can define the way of calculate its radius. Okay, so I want to use impact score and another integer number to make the top 5 has larger size. Okay, so you can see that starting from this vertex that we have these 5 top impacted applications. And then in this case, you can see how impactful it is for one application, and what actions we take once one application is down. And the second use case is called
Xinyu, I have a question about the first query. How complex is the application network? Is there how many links?
We can check that from the loading data tab. Okay, so here application we have 1,600 about.
And you have to traverse like a few applications, like the impact?
Yes, I only traverse the subgraph.
Okay.
Yeah.
And how do you actually do the impact score?
I do it layer by layer.
Okay.
Every time vertex is visited, I will add some weight to it.
Okay.
Okay. And if the distance is farther from the source, then I will just reduce the score. It is added to the weight.
Okay.
Yeah.
Sounds good.
And for second use case called warning impact, because as we can see that from the graph schema, we have warning attached to applications. So that means when a warning happens, the question we want to ask is, who should we contact? Okay, so I implement this very simple query starting from input warning and traverse all the way down to the manager and up to the subgraph. Okay, so let me try to cut this. Right, and you can see from the result, the green vertex is the warning, and we found the application. And further down, I found these two services that utilized the impacted the application. And then the Raymond Constantino and the Tammy Moses are the project owners that we should contact by giving this arrow.
Yeah, this is a great example that we can find the impacted components according to business units and product owners, and we can really visualize and find information out of this, right?
Yeah.
Do we actually use like multi-graph here, or we can if we want to?
Of course, we can use multi-graph.
Okay, cool.
Yeah. So that we can hide something that from other department, something like that.
Okay.
Yeah. Okay, so the last use case is called storage impact. So the idea of this use case, if something goes wrong with the storage system, it can happen on any layer. Something wrong with the LAN, something wrong with the pool, or something wrong with the storage array. Then what would be the impact to any layer of this architecture? So we can ask questions, what is the impact to service level? What is the impact to application level? So I just specify the name of the level here and put the LAN ID here. Okay, then from the result, you can see if this LAN goes wrong, it will further impact all these host servers, which they have this 1,500 applications deployed on those servers. And then further down, it will ultimately impact the service of 917.
Okay, can we put kind of a threshold on the different storage here, or this query here just looking at what are the problematic components and how it affects the downstream or upstream components?
Yeah.
But if we can also put kind of the alerting on different components as well, right? For example, like the storage, it gets to 80% capacity, it might get problematic.
Of course.
So we can also do that type of insights.
Yeah, the problem actually can be anything. It can be the capacity problem, it's overbooked, or there's some like system error or hardware issue. It can be anything, actually.
Okay, sounds good.
Yeah, and that's all the use cases that I have for today.
Okay, great. All right, let's recap what our presentation entails today. We walked through that, talked about how TigerGraph is naturally designed and fitted from the ground up to provide insights for the network and IT resource optimization problem. And Xinyu walked us through that use case in depth. And I want to remind everyone that our new solution sheets are coming soon. And our next episode is on the time series data. And that's actually really naturally fitted for the network IT resource as well. So we'll have another separate webinar on the time series data on February 13th. These are the additional resources for our new developer portal, and you can download Developer Edition, as well as the Guru scripts today will be uploaded to the GitHub repository, so you can reproduce in your POC environment. And definitely join our all kind of social forum that you can submit questions to us. All right, any questions? Let's go to the Q&A session. Victor.
Hi, Emma. This is Victor Lee, another product manager at TigerGraph. I have some questions that people wrote in that they sent in advance. People, since we seem to be talking about network and IT services, they're thinking about IoT. First of all, does this work for IoT applications?
Yes, so we will actually have another webinar on the IoT solutions, but it is actually, as we talked about earlier, IoT is a bigger solution, a problem space for this general topic. And as long as the IoT devices can provide the data input to TigerGraph, and then we can analyze the data. And if you're looking at the streaming data, our new Kafka loader, which will be coming out soon with a new edition, can connect the IoT data devices and importing to TigerGraph. We have very flexible data loader and it's performant and can import a lot of different formats, data formats, JSON, tabular formats, a CSV. Hope that answers the question.
Thanks. We do have a question that was just asked. Could you repeat, why is TigerGraph better for compute and querying these graphs than compared to a SQL database?
So a quick answer is with a SQL databases, it's organizing the table view. And when you are doing the analytics from one to the other, through multiple hops and links, you would have to use multiple joins. And with joins, we know that it will be less performant when you have multiple joins. And sometimes you're running into out of memory issue with relational databases. And with graph databases, when you model the data in a graph way, vertex and edges, it's already enables the traversal in a very efficient and performant way. And TigerGraph's implementation has we uses the MPP architecture, and we have very parallel computation for these type of deep link analytics.
Thanks. Yeah, I think maybe we can give a short presentation sometime on the architectural differences between relational databases and graph databases. But basically, when you're doing a join, you really have you have two separate tables, and you're reading through the tables to see where they have matching data values. So you have to read through the entire tables. With a graph, you already know the link. You're just following a pointer. So it's much faster with a graph database to do the equivalent join type operation. Another question. You mentioned that in your architecture for your IoT, you had different layers. How many layers could be represented in this graph? Is there a limit? Is there a performance limit?
So for we can do 10 plus layers because with our, as I mentioned earlier, our MPP architecture, we can actually do more than 10 hops. Each hop you can think about as a layer in the IT infrastructure. So with that, I think we don't have a limitation in the performance for the 10 plus layer compared to some other graph databases. I hope that answers the question.
Okay, and I have one more question. So in the use cases you're talking about, these seem to be sort of analytical queries, or such as contacting a person or seeing impact. Is this designed for offline analysis, or can it be used for real-time analysis? Can you do real-time updates of the network and real-time alerts?
Yes, actually for this type of query, it only traverses a subgraph. So the workload to TigerGraph is really small. So for this type of query, we are able to support a very high QPS and support online real-time system.
Yeah, so QPS is query per second. That's the short abbreviation for QPS.
Okay, what about the aspect of updating the data, the network status, so new information about the network can you do the real-time updates there?
Yeah, for sure. We have very good real-time update performance. The best performance I've ever seen is about like 1 million lines per second. So we have the capability to support real-time online real-time update, such as if you have sensor data that gives you new info every few minutes, or your server status changes, or you always have new application coming in for the storage system, we can handle all that. And we can handle very huge amount of those updates.
Would that be with a single server, or how many servers would you need?
Usually for this type of IoT graph, for this specific use case, single server is enough. But when you have very huge data set, we can create a distributed cluster to handle all that.
Great. So just want to make one more call to see if anyone else has a question that they want to ask us quickly. Oh, here is another one from Randy. This is a general question, so maybe direct this towards Emma. What are the advantages of TigerGraph versus Neo4j? Are these products in the same product space?
So I would say that from Neo4j, TigerGraph can cover most of the Neo4j use cases, actually all Neo4j use cases. From mostly technology-wise, TigerGraph is you can scale out in terms of performance, and it's actually a distributed, as well as scale up. TigerGraph is a distributed graph databases. And Neo4j so far, I think it's only scales up, and you cannot really scale out. So that's the main problem. That means TigerGraph can handle a lot more data, and you can do the real-time deep link analytics. And we actually have a benchmark comparing TigerGraph and Neo4j in terms of performance. And we'll see that more than 3 hops, I think TigerGraph can handle very easily, but Neo4j will have trouble if you're traversing more than 3 hops. And if translating back to how many layers of this hardware, Neo4j might be handling a 3-layer IT infrastructure here, whereas we can do 10+ layer. I hope that answers your question. I think there's more information online.
Okay, so you're saying basically scalability of TigerGraph is better, the ability to handle more hops per query, I guess on large graphs, and you suggest looking at the benchmark.
Yeah, and the benchmark really kind of translates to a faster loading with TigerGraph and the hardware efficiency.
Okay.
That you will need a lot less hardware hosting TigerGraph.
Less hardware, so lower total cost of operation of ownership.
Yeah.
Great. Yeah, Randy says thanks. So I want to thank our speakers, our presenters today, Emma Liu and Xinyu Chang. Thank everyone, and I think Xinyu and I will be back in a couple weeks with another Graph Guru webinar, episode 10. So we on analyzing time series data. So we look forward to being with you again. So please sign up, and thank you for your time.
Thank you.
Okay, thank you.